just had some nice discussions with other people on paradigm shifts, and that is a true statistical paradigm shift in the community, which usually is trained in a completely different mindset, and I will talk about these things in a second. Now, myself, I'm working on environmental issues. I'm very concerned about sustainability questions, and we're trying to use machine learning in that setup. So I'd like to introduce you to this mindset that we have, this discipline. It's actually myself working through these polar regions. It's really cold, so you can know that. Okay, so what's at stake? Obviously, with data mining, you get at a much better pre-screening of data. So you have information before you actually do the true analysis. So you have very quick and rapid assessment. The idea of rapid assessment, as Dan was pointing out earlier, is actually very important. You want a quick but accurate course solution. That would be great if you get to that idea. Data mining can help you there. And obviously machine learning can improve it. You also can draw better inferences. My inference is usually based on predictions. So I do predictions first before I care about anything else. Once I have good predictions, then I ask the question why. It's different than what people usually do. They fit the data first, and then they try to predict or do some generalization. There's some nice papers published on how poor the traditional way is actually performing if you transfer it. The transferability or generalization of knowledge is really poor if you follow the traditional approach. So you have a location, you build a linear regression, you apply it to Egypt, and it completely fails. You say, oh. So it would be much better to predict first and then work it backwards. So anyway, that's obviously a change in business. If you are still dealing with hypotheses, which many of us don't anymore, you will also see that machine learning can actually fine-tune your hypothesis. I'm not excluding hypothesis testing, but I think you can use machine learning in a very informative way to actually get better and more relevant hypotheses. It's a very hot issue with the idea of, if you're familiar with statistics, the idea of silly hypothesis. I would argue that most of our universities are occupied with silly hypotheses. There are many examples for it, actually widely published. Anyway, that's an interesting thing to get better hypotheses. It's also much faster, more accurate if you work with machine learning. Certainly the speed issue is convincing. I have students that spend like 12 months working on linear regression problems when you can do the same with CART within less than 2 weeks. So why spending so much time on it? The prediction obviously is very important that if you make that your main focus, so then you can actually be proactive. So you predict a risk before it occurs. That's really useful, certainly for people who deal with money, but also in the environmental sense. If we would have been able to avoid climate change, we should have done it. But because by now we really see how much of an issue it is, global sustainability question. And so basically with machine learning, you can move into progress in science and society. We are really dealing with this issue. And then we're also dealing with a new culture. And so if you want to reach a new culture, it's not only for us in the ivory tower, but in the real world, and certainly also with the new generation, which includes children. And we'll talk about this more. So what I will cover here is, first of all, I'll give an introduction into how we think in the environmental business, then about the paradigm shifts, how it actually applies to GIS, and then also, I think that's very important, to teach machine learning in public institutions. I have a colleague who's a statistician, and he's saying it's a big tragedy that our high schools don't teach maximum likelihood. I would actually argue it's true. It's also a great tragedy that we don't teach machine learning. I cannot see why boosted regression trees or Salford software or whatever software they use. Anyway, nothing stops you really to train students very early on in machine learning. And I think we should move there if you believe that machine learning is useful. Anyway, I will talk about these for the next half hour. Perhaps we have a good discussion after this. So the issue with the Earth is that we only have one. It's a big problem. We cannot just mess up one Earth and then go to the other one. We can try to fly to the moon or to Mars, but that's not realistic for most of us at least. It won't save millions of people, and it doesn't give us any jobs. So if you really are concerned about what you're doing, you must deal with the Earth one way or another. As a matter of fact, in the moment we have this major issue with this little, very tiny feature here around the Earth called the atmosphere, which we've completely polluted and messed up, but which really creates a major problem for most people in the world, basically all people in the world. And it's cost us currently, I think it's around 10% of the GDP. I would argue it's actually much higher than that. It will certainly affect the life of the new generation of our kids and of the generations to come for the next 200, 300 years at least. So that's a very serious issue. And the question is how to deal with that. Business as usual is dead, as you also know in the financial sector. We cannot continue as we've done before. So the environmental argument is really serious, and it must deal with global issues, with big data sets, and with complicated data sets, and with lack of knowledge and uncertainty. So I really like that TreeNet, for instance, can handle data gaps. That's a major progress, I think.